BioRecover. The European Commission has elaborated a list of critical raw materials, CRMs, that play a pivotal role in Europe's economy. In this context, BioRecover project seeks new sustainable and safe processes, mainly based on biotechnology, for selective extraction of CRMs like rare earths from bauxite residue, magnesium carbonate from calcination byproducts, and platinum group metals from tailings and PGM process residues. Let's see a summary of the different processes developed. Bauxite residue. BioRecover's bauxite residue is the insoluble material generated during the extraction of alumina from bauxite, or in the Bayer process, being one of the main European secondary raw materials for rare earths. In this process, firstly organic acids, mainly citric, are produced by fungi genus Aspergillus, obtaining, after several days, an effluent of them in a cell-free medium. The effluent is mixed with the bauxite residue, mobilizing the rare earths. Residue is separated at the end by membranes. The result is a solution where about 60 to 80% of rare earths are mobilized. Finally, the leachate is passed through an ion exchange column that traps the rare earths in the solution. This operation is repeated with selective microcapsules for each metal. Magnesium carbonate. Among the different wastes of magnesium available, a calcination byproduct with magnesium carbonate was selected, developing a process for it. First stage is conditioning the residue in a bioreactor with the growth medium. After that, the microorganism is inoculated in the bioreactor, producing sulfuric acid that leaches the magnesium present. After several days of bioleaching, a membrane's filtering system separates liquid and biomass. The liquid with magnesium is treated by electrodeposition to obtain brucite, magnesium hydroxide, a commercial product. Platinum group metals process residues. The bioleaching of platinum and palladium from PGM residues is another of the main goals in the BioRecover project. The designed process has 3 steps. First, the microorganisms are growth in a bioreactor producing sulfuric acid. This acid solution is filtered by microfiltration, like the other BioRecover processes, separating biomass and liquid. Finally, this acid medium is sent to a bioreactor with residue for the bioleaching process. Mobilization of platinum and palladium then takes place, including other metals present, lasting for several days. After, the bioleachate is filtered using the filtration system, separating the residual stream from the leachate. A mobilization of almost 60 and 80% of platinum and palladium, respectively, was achieved. The selective recovery process is achieved pumping the leachate throughout an adsorption column that contains modified siderophores in biopolymers, immobilizing palladium and platinum. Finally, the elution ammonium salt, getting a PGM concentrate solution. Tailings with platinum group metals. BioRecover has also studied the extraction of platinum group metals from tailings. The raw materials from a South African platinum mine are conditioned in a rotary splitter, obtaining representative samples. The raw material contains base metals, cobalt, chromium, copper, nickel and iron, and PGMs, platinum, palladium, rhodium, osmium, ruthenium and iridium, together with gold and silver are noble or precious metals. The microbial cultivation takes place in a stirred tank reactor, STR, in specific medium, adapted to remove interfering components like base metals in this pretreatment stage, obtaining a PGM-rich residue. The indigenous cyanide-producing microorganisms, cultured in lauria broth medium supplemented with glycine, biocyanide, that treat the PGMs, resulting in a PGM-rich solution. Finally, this PGM-rich solution is treated with biopolymers that recover the metals. The results of the BioRecover project demonstrate the possibility of obtaining critical raw materials from current unexploited sources, reducing their criticality, which is a key point for an effective UE green and digital transition. BioRecover involved 6 European Union countries and with the international cooperation from South Africa. This project has received funding from the European Union's Horizon 2020 Research and Innovation Programme under Grant Agreement number 821,096.